Okay guys, so this is very easy. Finally, you can easily do eye detection and tracking with less than 20 lines of code. Wow, this seems too good to be true, right? So let's dive straight into it and see how it's done. Alright guys, so finally let's get our hands dirty on writing some code. But as usual, before we start, let's look at the files we'll be using in this tutorial. So we are going to do this tutorial based on Mediapipe, and if you go to the Mediapipe website, you can get the various points on the human body. So these are the body landmarks, and in total we have 32 of them. But our aim for this tutorial is to be able to detect the eye, and if you can see clearly, the eye here, which is the right eye, is 0.5, and if you trace it to 0.5 here is the right eye, and then the second one is the left eye, which is 0.2 here, and when you come here is 0.2, which is the left eye. So what you have to do now is to be able to extract these points and get the correct coordinates. Then we can draw some circle to detect and also track this eye. So that's all we have to do in this tutorial. So let's get right into it and find these points out. Okay, so before we import our libraries, as usual, the codes we'll be writing in this tutorial will be on my GitHub repository. I'll put the link in the description so that you guys can have access to it. We'll first start by importing OpenCV. Then we'll also import the post detection module from CV Zone. Okay, so this is step 1 done. The next step is to get our feed from the webcam, and to do that we just have to create a capture object. So we say cap, which is equal to cv2 dot the video capture function. Okay, so the video capture function takes the camera you want to use, and it takes this in the form of numbers. So you can put in 0 here, which will probably be your first webcam's ID, and you can keep trying from 0, 1 and so on to get the right camera to work with, and that's if you have multiple cameras connected to your computer. So since I'm having one camera, I'll put in 0 there, and that works for me. Then we'll take this video in a loop. So we'll start by declaring a while loop. So we just say while true. So instead of writing true, it's a Boolean value. I can just put 1 here to make it simple. So I just say while 1, we want to get our feed. So it returns to us red and also our image. So we'll put it image or video, anyhow you store it, and this is equal to cap.read. Then it takes no argument. So red here shows the absence of video or not. So if there is no video, red here will be 0. It's also a Boolean value. If there is video, it will be 1, which is true in this case. But all we have interest in is our image now, or our video from the webcam. Now after taking it, guess what we have to do? We have to show it on the screen. So to show it, we also have a cv2 function for that. So you go cv2.imShow to show it, and what you have to specify in this function is the window name on which you have to show it. So you can just put frame here. Anything you put here works, but usually I prefer to put frame here. And then the next one is what you want to show. In this case, we want to show our image. After this, we have to wait and take each frame per second. So we have the function cv2.waitKey. Then you put in 1 here to take each frame 1 second. So it doesn't accept floating point values. Don't be tempted to put 0.5 or something there. It only accepts integers. Okay, so I think we can test this out to see whether it works. So I'll quickly run this. Okay guys, so you can see me live. This is working. So we have step 2 out of the way. We'll continue now by detecting our post, and to do that is pretty simple because we have CV Zone backing. all the necessary processing we need to do. So we just create a post object or post detector object. I'll call it PD, and this is equal to our post detector, and that's all. So there are a couple of parameters you can specify here, but let's leave it for now, such as the detection confidence. You can specify the tracking confidence, you can specify, but by default is 50%. So to get our post, we can just now call our object. So we'll say pd dot find post, and this takes in our image. So after putting this in, our post will be detected. So let's try it out. Okay, so guys, you can see we are getting our post detection on. So what we need now is to get the landmarks from this post. So as you can see on this body, we have various points, about 32 points. So now we have to go on to find these points, and then out of these points we select the particular points we want to work with, which is 5 and 2 in this case. So to do that, we have another function which will come here, and this function will return us with our bounding box and our landmark list. So we'll call the landmark list lm list for landmark list, and then we'll also specify our bounding box, which is equal to pd dot find post distance. Okay, find post position, not distance. So the find post position takes in our image, and then it will find the various landmarks on our body. So we can just print it out to see. So I'm printing lm this, and I'll also run this to see whether we'll get some points. And here we go, guys. You can see we have a lot of points. So let me raise the terminal. So you can see we have a lot of points. So these are the points is currently detecting on our body, and we have these points down here. So we have from index 0, 1, and so on. So we have 32 of these points on our body, but we are interested in 0.5 and 4 in order to track our eye. So that's what we have to go ahead and do. We have to be able to extract 0.5 and 4 from all these points. So let's do that. Okay, so all our points now is in the variable lm list, and we are just printing lm list. And I'll also specify draw here to be false. We don't want it to draw, so draw is equal to 0. Also we can stop drawing the landmark here, so we can say also draw is equal to 0. And now before we go ahead to get those points, we have to first check whether we have a landmark list. Because what if we run our script and there is no object or there is no human being in the camera? It is going to give us some error if we are not checking whether there is a landmark list before we are doing our computations. So we can say if the length of our landmark list, which is lm list, is not equal to 0. So if the length of our landmark list is not equal to 0, that's where we'll go ahead and perform our computations, or we'll go ahead and find our landmarks. So to find a particular point on the body, how do we do that? Okay, let's say we want to find the let me see, let's read this up. We want to find the that's the right eye, which is 5. Okay, let me get it right. It's right, 5 for the right eye. How do we find that? So we can just put it in a variable called right eye, and this is equal to our landmark list at the index of 5. So this is very simple to do. You just do it like this and you get your those values. So let's print right eye to see the values we'll get. Okay, so let me lower this off. You can see clearly we are getting a list here which contains 4 values. So the first value here is the particular index, and these 2 values here are the center S and the center Y. So these are the values we need now in order to track this eye. If you are able to track these two values of this list, we can be able to track the eye. So we can perform some list slicing here in this case to get these two values, and then we'll draw a circle to verify whether we are actually tracking or getting the point for the eye. So to do that, we can come here and say RX, which stands for right X, that means right eye X. It's very weird to use a variable like this, but let's just try it. And then we'll do RY also, which is right eye Y, is equal to our LM list. Okay, not our LM list, our right eye. Then we have to slice, so now we have to slice only these two values. So that means the first index is not part, so we'll start from 1, and then we have to end at the third one, but we can use -1 here to exclude the last one, so that in this case we will just get the two values within the list. So to confirm this, we can draw a circle. You can say cv2.circle, then we put in our image followed by our points. So the points now will be XR, RX, sorry, that's RX and RY. The radius, let's make it 5. Then our color, let's make this red. A thickness of 4 wouldn't be bad. We can change this anytime we want. So let's run this to verify. Alright, you can see we are tracking the right eye. When I move, you can see the red is still on it. So we are accurately doing this, and we can do same for the left eye in this case. So let's go ahead and do that, and we can also increase the radius of our point so that we get it big, and the thickness as well. So I'll say maybe let's do it 10 and see, and then the thickness, let's make it 5. Okay, so to do this for the left eye, I think we can just copy this same thing and just change the values. So we can come here, let's get rid of this print statement. Come here and say, we can comment right eye. I say here is the left eye. Okay, so instead of right eye here, let's put left eye, and then the key for the left eye is 2 here. So instead of 5 for right, we have to change this to 2. Then the slicing will be the same because it also have 4 values, and we want to take the middle 2. So let's make this one LR and LY. Another left eye here. So we'll change this also to LR. That's LX, not bad. And LY. So let's try this out. Okay, so you can see we are still tracking the eye, and now we are getting the values for the 2 eyes. I can see this is flickering, it's not targeting the eye, though it's trying to track it. Even when I move, try to track the eye, and this is working nice. Though there are other means to get something decent than this, and we are going to try that in our next tutorial, but I think this is fine. It's okay, working nice. What we can also do here is, instead of giving it a value, we can just fill it by just using -1. So this will just fill the whole circle around the eye. So okay, this is fine now. So guys, this is working, this is very nice, and most importantly, you can see we are doing this with only few lines of code. So this less than 20 lines of code because it's 23 or 29 here, but we've left a lot of space behind. So with only few lines of code, we are able to achieve this decent result, all thanks to Mediapipe for their awesome works. We are able to track this eye very well, and this works very nicely. So guys, thanks for tuning in. Thanks for watching this tutorial. If you've learned something new, do your best by sharing with your friend 2 or 3 so that we get large audience watching this. Once again, thank you so much, and I will see you in the next tutorial.